In the previous lesson, we studied sequences, the definition of arithmetic progression, the first term of an arithmetic progression, the common difference, and their interrelation. In this lesson, we will study how to find the nth term of an arithmetic progression when the first few terms are given. Given the first term and the common difference, we can derive some further terms such as a equals 3, d equals 7, the first term equals 3 and the second term equals 3 plus 7, that is 10. The third term equals 10 plus 7, that is 17. If there are 100 terms in this sequence, then finding the number at the 80th position will be very complicated using this method. So, let us explore a different method for this. For this, we need to examine how the arithmetic terms are formed. Now suppose the first term equals T1 equals A and the common difference is D. The first term equals A. Adding the common difference D to the first term gives us the second term. Therefore, second term is equal to T2 is equal to first term plus common difference is equal to A plus D. Therefore, second term is equal to A plus D. Third term is equal to T3 is equal to second term plus common difference is equal to A plus 2D. Thus, if we want to find the nth term, we multiply D, that is the common difference, by n minus 1 and add the first term, that is A, to it. Therefore, nth term is equal to Tn is equal to first term plus n minus 1, common difference is equal to A plus n minus 1 into D. Hence, formula to find nth term is Tn is equal to A plus n minus 1 into D. Now let's solve some examples using this formula. The first term of an arithmetic progression is 5 and the common difference is 3. Find the 10th term. Solution. A is equal to 5, D is equal to 3 and n is equal to 10. According to the formula, the nth term Tn is equal to A plus n minus 1 into D. Therefore, T10 is equal to 5 plus 10 minus 1 into 3 is equal to 5 plus 9 into 3 is equal to 5 plus 27 is equal to 32. Therefore, the 10th term is equal to 32. If the fifth term of an arithmetic progression is 12 and the 15th term is 42, find the 25th term of the arithmetic progression. Solution. Here, the 5th and the 15th term are given. Therefore, T5 is equal to 12 and T15 is equal to 42. We want to find the 25th term. For this, we will use the formula for finding the nth term. Tn is equal to A plus n minus 1 into D. When Tn is equal to T5, n is equal to 5. Therefore, T5 is equal to A plus 5 minus 1 into D. Therefore, 12 is equal to A plus 4D. Equation 1. As Tn is equal to 5, when Tn is equal to T15, n is equal to 15. Therefore, T15 is equal to A plus 15 minus 1 into D. Therefore, 42 is equal to A plus 14D. This is equation 2. As n is equal to 15. Equation 1 and 2 are linear equations in two variables. We'll get the first term and the common difference by solving them simultaneously. Now from the first equation, 12 is equal to A plus 4D. This is equation 1. Therefore, A is equal to 12 minus 4D. This is equation 3. Now, let's substitute this value of A in the second equation. The second equation was 42 is equal to A plus 14D. Therefore, 42 is equal to 12 minus 4D plus 14D from equation 3. Therefore, 42 is equal to 12 minus 4D plus 14D is equal to 12 plus 10D. Therefore, 10D is equal to 42 minus 12 is equal to 30. Therefore, 10D is equal to 30 and therefore D is equal to 3. Now, this is equation 4. That is, the value of the common difference D is 30. Now, let us substitute this value in equation 1 to obtain A. From the first equation, 12 is equal to A plus 4D. Therefore, 12 is equal to A plus 4 into 3 from equation 4. Therefore, 12 is equal to A plus 12 and therefore A is equal to 0. That is, the value of the first term A is 0. Now, given the first term A and the common difference D, we want to find the 25th term, that is T25. For this, we will again use the formula for finding the nth term, that is Tn is equal to A plus n minus 1 into D. Here Tn is equal to T25, so n is equal to 25. Therefore, T25 is equal to A plus 25 minus 1 into D. Substituting A is equal to 0 and D is equal to 3, T25 is equal to 0 plus 24 into 3 is equal to 0 plus 72 is equal to 72. Hence, the 25th term is 72. In the next lesson, we learn about the sum of the first n terms of an arithmetic progression. What did we learn? The definition of common difference and arithmetic progression and solved examples based on them. Formula for common difference, that is D equals T into n plus 1 minus Tn. The formula for finding the nth term, Tn equals A plus n minus 1 into D, and its applications. Exercise. Find the 10th term in the progression whose first term A is equal to 15 and common difference D is equal to minus 3. 7, 13, 19, 25. Find the 60th term in this progression. If Tn is equal to 301, find the value of n. Find the position of 20 upon 3 in the arithmetic progression 2 upon 3, 1, 4 upon 3, 5 upon 3. If the 8th term of an arithmetic progression is 17 upon 3 and the 12th term is 29 upon 3, find the 20th term. If a term in an arithmetic progression is minus 80, the first term is minus 5 and the common difference is minus 5, then find the number n of that term. Is minus 4, minus 1, 2, 5, minus 40 a term of the above sequence? If yes, find its position.